Welcome to the lesson on circular motion. We're going to start off with the warm-up here. So we've been asked to convert these parametric equations back into rectangular, so our normal ones. And whenever we see this trig values in here, our thought process is that we're going to be substituting them into sine squared plus cosine squared equals 1. So to do that, I'm going to get the trig values by themselves. So remember that we do that by subtracting the 3, dividing by the 6. That gives us this. We're going to end up squaring that. I will add the 2, divide by 6. That gives us sine. So now if I plug these into sine squared plus cosine squared equals 1, I will have x minus 3. Oh boy. I will have x minus 3 squared over 36 plus y plus 2 squared over 36 equals 1. Whenever the bases are the same, we typically move it over to the other side. So we'll get this. So this is a circle. If we really want to know, it has a center of 3, -2 with a radius of 6. Okay, so we're going to be creating these types of equations later on today so that we can model circles. For warm-up number 2, we're being asked to find the angular velocity of something, and this is going to make an appearance in this chapter again, so we want to make sure that we're familiar with it. So as always, we're going to start with this given information here. So we have 400 revs per minute, and I want to try to end up with radians per second. So first thing we could do is try to get rid of minutes. So I'm going to do a nice unit conversion, 1 minute every 60 seconds. So that's going to get rid of the units of minutes. Next, I need to turn revolutions into radians. So I need to try to figure out a nice conversion between revolutions and radians. So in one complete revolution, there are 2 pi radians, 360 degrees. So that will cancel out those. Now I just need to simplify. So I'm doing this without a calculator real quick. So I'll have 40 pi over 30, which will reduce 400 pi over 30, which reduces to 40 pi over 3 radians per second. Ta-da! Done. So when you first learned about ellipses last year in conic sections, this was kind of the base equation. Now you probably used A's and B's down here. Another way of thinking about that is basically a radius in the x direction and a radius in the y direction. And that's just another way of thinking about it. So if this is the rectangular equation, so xy equation, we can connect that basically like we did in warm-up number 1 back to parametric equations. So here's just one way that this would look in parametrics. Now I'm going to leave a tiny space right there because I'm going to add something in there. And then we would have the y equation, again leaving a tiny space right there so I can add something. So this would give us the green equation. So purple equations, if we eliminated the parameter, so we got rid of t, then we would end up with the green equations. So this is the base set of equations for modeling circular motion. Now the thing that we need to add in here is this, it's technically an omega I think or something, I don't remember what symbol it is. This is weird W looking Greek symbol. And what it basically is modeling is how fast this thing is actually rotating. Okay, so this is going to be like a rotational speed or an angular velocity. That's really what I should probably write there, huh? Angular velocity. And that's going to be measured in radians per time unit, okay? And what ends up happening then is it's W times T. T is measured in the time value, so it will cancel out the units of time inside of the trig function so that only the radian or the angle measurement will actually be in there. It serves an important purpose. But if they don't tell us how fast something's rotating, we always just assume it's 1 to make our life much easier. Now let's look at just a couple other things. We have x is equal to the radius in the x direction, cosine, this wt, and t, it's really important, is inside the parentheses for a circle, plus h, so this is the center point of the circle for the x value, k is going to be the center for the y value, and then we have all of this. Not feeling like I'm doing a great job explaining this, so let's hope this works out. What I want us to do is try example 1, and then we're going to try exploring a whole bunch of things off of that. So it says we got a merry-go-round traveling counterclockwise. So that's interesting. We're going to have to figure out a way of dealing with that. So counterclockwise is going that way around the circle. We have a radius of 30 feet rotating at pi over 50 radians per second. Find a set of parametric equations. So let's think about this. We have a merry-go-round, okay, which I'm going to draw right here. And what I need to do is have 0, 0 somewhere. So typically we don't put 0, 0 in dead center of a circle. We typically put it so that it's at the bottom, so that the y value is never going negative when it comes to circles. It's not always, but particularly real life problems, we don't allow y to go negative, because it generally means below ground, although merry-go-rounds are going kind of with the ground, not like a Ferris wheel that might be going into the ground. That would be bad. But typically we're going to allow this to be 0, 0, which means that the center of this thing with a radius of 30 is going to be up at 0, 30. So if I go to write the equations over here, the equation for the x value is going to be 30 for its radius because it's the same. Let's just leave it as cosine for now. The speed was pi over 50. We put the t value there. We're letting x be 0, so we're done with that equation. Y is going to be 30 sine pi over 50 t plus 30, and that's just going to move it up so that this is the center right there at 0, 30. And then, as always, we need to include our interval for the t value. So we end up with this. Have we taken into account this counterclockwise? That's an important aspect of this that we need to make sure we've figured out. So let's actually, I'm going to throw stuff apparently. Let's actually look at this x value here. So x is modeled by cosine. And what do we know about cosine? Cosine starts up here and it goes down and then back up. And the y value is modeled by sine. So let me just draw a quick little sine value. It starts here and it goes up and then down. So making these connections back to this circle graph is really, really important. Particularly what's happening here, here, and then also where this first direction is going and where this first direction is going. So the x value needs to start at a positive maximum value and then decrease. So let's think about where on this circle, okay, is x at a positive maximum value. And it's going to be right here. So this is where x is at its maximum, right? It can't go further in the right-hand direction. And then let's think about what happens here. The x value is going to decrease, right? And that makes sense. If I go in either direction around this circle, the x value is going to be decreasing, heading towards 0, because this is an x value of 0 right there. So we know right now that our equation has us starting right here because it's the only place that x is at a maximum. And since x is modeled by cosine and cosine starts at a maximum, we know that we have to start here. So that's the key thing that we got going on right now. This x equation told us that we're starting our model right there. Now, the next part's going to be a little bit trickier. So let's look at the y equation. Y is starting at 0. Okay. Now, is our y value starting at 0? Not exactly, right? If this is our start point, our y value is actually going to be 30, and it's not 0, 30. Sorry, it's 30, 30. But our y value when we're right here is equal to 30. But let's think about this. This says y should equal 0, but that only takes into account that part of it, the sine graph part. So if this part is 0 plus 30, that brings us right there. So this point lines up that that is in fact our start point, but it's going to tell us our direction. So looking at this, it says that the y values will increase, go more positive. So from this start point, we have to go this way because that's the only way that y values increase. If we went this way, down, the y values would decrease. So we now know that this equation right here, because we used sine and cosine for the x and the y, just like we did, okay, that this is starting over here and it's traveling in that direction. Now, this doesn't say anything about a start, but it does talk about the direction, counterclockwise, and we are going counterclockwise because we are going up. And this is the hardest part about what we're doing here, is figuring out this set of connecting these graphs back to this sine and cosine. Because what I haven't told you yet, and I probably should, is that these sines and cosines over here, we could switch them. We could let x equal sine, and we could let y equal cosine. And if we throw a negative sign in front of them, then everything can change about them. And that's what we're going to be playing around with in the next example, is trying to figure out, okay, if x is a sine value, what does that do to the graph? If y is a cosine value, what does that do to the graph? So let's look at example 2, and then we'll come back and try to summarize what we learned, hopefully. All right, for example 2, it says, sketch a graph of these circles centered on the origin with a radius of 1. So if we look at all of them, we know that they're centered on the origin because we're not adding anything to them. And the base equation says we would add plus h plus k for the center. We know the radius is 1 because all of them have a 1 in front of the trig function. So what it comes down to next is that we need to figure out where they start and which direction they're going in. Okay, so let's take a look at this first one. We have x equals sine. So I'm just going to sketch a quick graph of what sine looks like. Okay, that's the x value, and the y values are cosine, so I'm going to do that. So let's start off by just drawing a circle that is centered on 0, 0, has a radius of 1, and what we want to do is just label where we're starting and then which direction we're going in. Okay, so let's think about this. We know that the x value starts at 0. So if we're looking at these things, x starts at 0 is either going to be here on the circle or here on the circle. So that doesn't help us because we need to narrow it down a little bit more. So let's look at the y value. The y value, which is cosine, starts at a maximum. Okay, so of these 2 points that we've already narrowed it down, only one of them is at a maximum, which is this one. So because y is cosine, we know that we're starting here. Okay? Now let's figure out the direction. That's where x is going to come into play. So x is sine, positive sign, and it increases first. So from this point, if we travel around the circle, if we were to go left, okay, so in the counterclockwise direction, that would go negative x. And we know that x is going up. So that means that this graph goes this way. So if x equals sine and y equals cosine, then we're starting at the top going clockwise. So what I'd really like you to do is see if you can figure out B, C, and D on your own before you watch the video on it. And I know that that's not going to be easy for you necessarily, but please pause the video, try to do B, C, and D on your own, and then pick it back up. What if I just awkwardly waited in the video for like 3 minutes to force you to do this and not tell you when I'm going to fast forward, cut? No? Shouldn't do that? Okay. I won't. For B, x equals cosine, y equals negative sine. So let's sketch a quick graph of cosine. For the x value, for the y value, it's going to be negative sine. Okay, so negative sine is going to start at 0 and go down. So here is our circle. We again just want to figure out where do we start and which direction are we going in. So I'm going to look at the cosine one because that cosine one in part A helped us figure out where we start. And it says that x starts at a maximum, and there's only one place on this graph where x is at a maximum, which is right here. So this guy helped us figure out where we started. Now y is negative sine. Okay, so that means that the y values start at 0, and conveniently the y values at this point are 0, and then they decrease. So from this point, for y values to decrease, we have to go that way. So this graph is starting over here at the 3 o'clock position on the clock, and it is going clockwise still. If we do this one, again, I'm just going to sketch a quick graph of sine and cosine. So negative sine goes down first, positive cosine starts at the top. Got my circle going on right here, pushing my whole board all around. I'm going to look at this first. So it says y is cosine, y starts at a maximum. There's only one maximum for y, which is right there. X is negative sine, which means we're going in the negative x direction to begin with. So that means that I'm traveling this way. So for this graph, it starts at the top, but it is going counterclockwise. These guys are a little bit trickier to figure out, to be honest with you. We don't do them super often with this addition in here, but let's just do a quick sketch of it. This pi over 2 means that I'm shifting the graph over to the left pi over 2. So when I do that, my first point is going to be here, and then I'm going to come down and draw the cosine graph. Same thing for sine. It's going to start at 0 here and then draw its sine graph. We still care about what's happening at t equals 0, which is on this graph right here. So the y value is at a maximum, and here the x value is at 0 and then decreasing. So when we have our circle, sorry that's a different color for those of you who are freaking out about that, I have a y value up here at a maximum, and then the x values need to decrease. So I'm going this way. So these two actually give us the same exact model, but slightly differently. Now, if we take a pause and think about this for a second, if x was cosine and y was sine, just normally, okay? So if x is cosine, y is sine, this graph would have started right here and gone counterclockwise. And this plus pi over 2 moved the start point pi over 2 away from where it was, in the direction it was rotating. So as long as we know where x equals cosine and y equals sine starts, we could actually just rotate by whatever the angle is in there. So if this had just said t plus pi over 6, then this would have started at pi over 6 right here, and it would have gone that way. So doing the addition is a really good way of getting any angle if you don't want to start at one of the quadrantal angles. So to summarize, okay, I'm going to try to squeeze it into this little box. We're going to, if you're given an equation, you're always going to look at the cosine one, because that's going to help you figure out where you start. This was supposed to be an arrow. It's a really bad one. So if you notice on every single one of these, we focused in on cosine first to tell us where we start, no matter where it was, okay? From there, we use the one that's sine to tell us which direction it's rotating in, okay? So for this one, we knew we were starting here, positive sine, so we're going in a positive x direction. Here it was negative sine, so we went in a negative y direction. Negative sine, negative x direction. And that's going to be our summary of what's going on. Now, if we're working backwards, meaning that we're trying to write the equations, we have to try to think about this as well. And that's what example 3 is all about. So for example 3, we have parametric equations that trace a circle with a radius of 2, and what we're going to assume is that it's centered at 0, 0. Okay, so here I have a big old circle with a radius of 2. So this point right here is 2, 0, 0, 2, negative 2, 0, which is where we're starting for this first one. And down here would be 0, negative 2. So for this one, we want to start over here, and we want to go clockwise, which means we want to go up. So let's go about writing these parametric equations. I'm going to start off with the x and the y. And I know that the radius is going to be 2, so I'm going to just put a 2 here. And now we got to figure out which one's sine and which one's cosine. So at this starting point, is this at a maximum x or y, or minimum x or y? And this is at a minimum in the x direction, right? We never go more to the left. So that tells me that that's my starting point, is the x values, and that it's a negative cosine. Negative because I'm starting at a minimum instead of at a maximum. That means that my y equation will be the sine, because there's always one cosine and one sine when we're doing these, never both cosine or both sine. That would do really weird stuff. And that's going to help us capture the direction now. So the direction is that we're going in a positive direction. So that means that this is going to be positive sine of t. Done with 3a. For 3b, this time we want to start at 0, 2, so that's going to be right here on the circle, and we want to go counterclockwise, so that's rotating this way. So again, we're going to look at this first starting point, and that's going to help us figure out which one is cosine. So it's going to be the y value, because this is a y value at a minimum on the circle, so y is going to be the negative cosine. And then we need to go in a positive x direction. So from this point, we're rotating in a positive x direction. So x is going to be positive sine. So I hope you're starting to get the feel for this, that the starting point tells us which one's cosine, either x or y, and that the direction tells us which one is sine. We're moving in a positive x direction versus a negative x direction. Up here, we're moving in a positive y direction versus a negative y direction. For example 4, we're being asked to write a parametric equations for this. So we recognize this as an ellipse. There's two things squared with a plus sign in there. So we know that this is going to be modeled with the types of equations that we're doing here. There's a couple things that we want to take note of. They did not give us any sort of direction, which means we can start it any way we want. They did not give us a starting point. So I guess that's the one that I should say that where you can start anywhere we want. That one is we can go whichever direction we want. So that means that this is really easy. So I'm going to use the base equations, which is the one where we let x equal cosine, because that's our basic one that we use. And I will let y equal sine. Again, that's just basically because we're used to that, right? X equaling cosine, y equaling sine. Those are our base equations. Plus, those start at the traditional trig value, and they automatically go in the counterclockwise direction. So it's just what we're used to with everything we've been doing so far this year. So let's think about this. They didn't give us a direction. So that means I don't care about w. So I'm going to let w equal 1 and not think about it. That says w equal 1. Oh my goodness. I don't know what's going on there. And let's see if we can pull some other stuff out. The h and the k. So we have that up here. We know that the center of this ellipse is going to be at -3, 4. This is going to equal the radius in the x direction squared. This is going to be the radius in the y direction squared. So we can basically plug in everything we need to know. So radius in the x direction is 2. I'll do cosine. I'm letting w equal 1. So I'm just going to put t in the parentheses and then -3 to get that starting point. Y is going to be 4. That is the radius in the y direction. Sine, parentheses t, inside, plus 4. And then all I got to do is just put some sort of interval there. We don't really care because they didn't tell us about it, but it's nice to include an interval. And there you have it. That is modeling circles. So just to summarize one last time, that whichever one is cosine is going to tell you where you start, and whichever one is sine is going to tell you your direction. So with this exact one right here that I had, this cosine told me I was starting at a maximum x value. So on a circle, the maximum x value is right here. So that is why we started there. Y is positive sine, which means we're going to go up, because sine normally starts at 0 and then goes up. So we started here and we went up. So this is the key. That's what you need to remember. Whichever one is cosine is telling you where you're starting on the circle. Whichever one is sine is telling you which direction you're going to. This is a disaster. Not going too well, I feel.